Okay class, so this is a special lecture which I am recording as a tutorial, okay, for the function generator. Okay, so you must have received these devices, that is function generator, oscilloscope and digital multimeter. So to help you operate these equipments, we are sending you these tutorials to use these equipments. Okay, so this particular tutorial is for the function generator. So the function generator which we'll be using in this particular course, okay, so it's mainly used to generate and manipulate signals, okay, which we also call as waveforms of different types. So we'll see what different types of functions or waveforms we'll be using. So the machine can particularly generate sine wave, or can generate a triangular wave, or can generate a rectangle, depending how you look into it. For most of you, the function generator which we have sent is this AppLab SG1610C. Okay, so I'm recording this particular tutorial for this particular model. Okay, but in any other case, whatever be the function generator, it will be very similar to this particular model. Okay, otherwise, if you feel any difficulty in using that particular function generator, we can just provide some additional short video lecture or something like that. So in this tutorial, we will learn how to operate and use various features of the function generator. Okay, ignore this line. So this is how the front panel of the function generator look like, this AppLab SC1610C. So what you see, the first button which will be useful to you is this power button. Now before you switch on the power button, you make sure that all these knobs, they are in their correct position. Okay, so this power button is to switch on this particular machine. Now you have to take an output. That means you have to take different signals from this particular function generator. So for that, you have been given the 4 BNCs over here. So this particular BNC, this one, and this one. And beneath each BNC, something is written. Okay, so like it's written here that this particular BNC is for external frequency input. That means you will be using this BNC connection if you want to give input of a certain frequency to this function generator, which you don't want, so you will never be using this particular BNC. The second one is for single pulse output. So it will just give you one pulse and that's it. So we will also not be using this, but we will never be using this particular connection for this course. But you know that it will generate one pulse, and that pulse can be used for external triggering. If you want to trigger something with some pulse, you generate a one particular pulse. Okay, but that's not really required for this course, so we will not be using this output. Now this leaves us with these two. Okay, 50 ohm output and TTL or CMOS output. So as says, and as also discussed by Professor Kelkar in his first lecture, that the output impedance of a function generator should be as small as possible. So if you take output from this particular BNC, it will have the output impedance as 50 ohm. So it will give you a normal sine wave with the output impedance of the machine as 50 ohm. And if you want to, whenever you want to use this function generator for digital experiments where you want to use a square pulse, so there is a difference between square wave and square pulse. Okay, so we'll come to that in a while. So for whenever you want to generate a square pulse, square pulse or TTL pulse, you will be using this particular output from this particular BNC. So these are the only two BNCs you will be using for most of your experiments. Now you connect your BNC cable to your actual output, either this one or this one, and then take the output to your at the right position. For example, if you want to give this signal as an input to op-amp or any other device, transistors for amplification or whatsoever, you will be taking the signal from here. Now the signal should be of which form? Second comes this waveform. So like it's shown over here, the waveform can be of three types. Okay, either sinusoidal or triangular or rectangular. So the moment you switch it on, any one of these light will glow. That means the output is of the form of sine wave or triangular wave or rectangular wave. If you don't want that, or you want to change the the waveform type, you just press this button, the waveform button, multiple times, so that you can toggle between the three types of waveforms, and then you select the right one. Here also, for most of the experiments, you will be using the sine wave, but for certain experiments, for example integration, you may use this or this. Okay, so this basically to select which particular waveform. Now this knob, it's written, it's a frequency, so that means changing this knob will basically increase or decrease frequency, and this knob rotates continuously. That means and this is basically the display for the frequency. So you will read frequency over here and amplitude in this particular panel, SSD, 7-segment displays. Okay, and here you have these numbers. So that means that tells you the order of magnitude of the frequency. So this is 1 Hz, 10 Hz, 100 Hz, 1 kilohertz, 10 kilohertz, 100 kilohertz, 1 megahertz, and 10 megahertz. Now you read this one. The bandwidth of this particular function generator is 10 megahertz. That means all this that any signal which is generated by this function generator, which is below or equal to this particular frequency, you can trust the output. Okay, if you take the signal whose frequency is larger than this one, that means so you have crossed its band, this upper cut of frequency. That means its power output, okay, or voltage output will start decreasing. So you will not be able to trust the power drawn from this function generator. So this can fairly be used for any signals equal to or below this upper cut of frequency or bandwidth. Okay, so you will be reading the frequency over here with the range over here, and then amplitude over here. So if you want to fine tune the frequency, you use this frequency knob, and if you want to jump between the order of magnitude, then you use this range button. Okay, by clicking this right range button or the left range button, you will be switching between the order of magnitude. For example, if you are at 10 and you want to go to 100 Hertz, in the range of 100 Hertz, and you want to go to 10 kilohertz, you just press this button twice, and then suddenly the frequency will change to in the range of 10 kilohertz. Okay, here you will be reading the amplitude, and this is the knob for the amplitude. Amplitude can be read in the different form. So the unit will be either in volt or in millivolt. Either these two LEDs will be on. Okay, and the amplitude will be reading either in the peak to peak or in RMS. So RMS is basically the amplitude divided by √2. Okay, and peak to peak is from here to here. So this is simply your amplitude. This is peak to peak. Amplitude divided by root 2 is RMS. So depending whether the signal is volt or in millivolts, and whether you are measuring the peak to peak or RMS, respective these buttons, they will glow. Okay, now to increase the amplitude, you have to rotate the knob clockwise or anti-clockwise, and you will see those readings in this particular display. Now if you are at a minimum amplitude, okay, so it will be around, let's say, half volt or even 0.1 volt or 0.2 volt. That is the minimum amplitude you will see from here. But if you want to decrease amplitude even to millivolt or to microvolt, that you cannot control with this knob. Okay, in that case you have to use this button called as attenuation. So you see these four particular displays over here written as 0 dB, and then 20 dB. Similarly, this is 40 dB, and this is 60 dB. Okay, so 0 dB means that there is no attenuation. If you press this button once, this light will be switched off and this light will switch on, and you will read this 20 dB will be illuminated, and you will understand that now you are using 20 dB attenuation. That means the amplitude will decrease by a factor of 10. If you press this attenuation button again, 40 dB attenuation will be enabled. That means amplitude will be disabled by factor of 1000. Sorry, factor of 100. And similarly here it will be factor of 1000. So each this 20 dB changes the frequency by 1/10. Okay, so that will be useful if you want to change the frequencies from volts to millivolts, even to microvolts. Okay, so you understood this range, waveform, attenuation, and this amplitude. So this amplitude button you can use if you want to change the display from peak to peak or RMS. You press this button, you will be reading the voltage output in the form of peak to peak, and you press this button again, you'll be reading the voltage output in the form of RMS voltage. Now comes this mode, and this mode is associated with these 8 LEDs. You will not be using this particular part of functionator, so I am leaving this segment, or will probably tell you this later on. Okay, this is also for the sweeping or modulation, which also we will not be using, so ignore that. Ignore this also. Once you take the output from this right hand side BNC for the TTL or CMOS, and then you want to adjust the signal, in that case you will be using this particular knob, CMOS adjust or TTL adjust. Okay, so this is regarding the various features of and various knobs and various connections of your this AppLab function generator. So this I kind of made this particular video so that you understand each of these knobs. Okay, very soon I am just going to use this function generator in connection with the CRO, and we'll be taking output from all these things, and we'll be playing with these buttons and knobs so that you understand the function of these things precisely. Okay, so I think I have not missed anything in the front panel. Well, of course, this whole machine is powered by from your electrical mains. So on the back end side of this panel, you have this connector for this 220 volt, which basically powers the whole function generator. So you connect that, and then you switch on. You press this power button before you. There are a few things which I have left. This symmetry and the DC level. So let me come to that. So what is the meaning of symmetric and DC level? So for example, let's say you are taking output from this 50 volt 50 ohm output impedance, and you are using a sine wave. So normally the sine wave will look like this one, and you will get this sine wave. Actually, I made it quite asymmetric. Something like that. Okay. Now, for all your experiments, until you know what you are going to do with these two buttons, they will always be in the off position. Before you start using the function generator, you cross check that amplitude is close to minimum. This is minimum, and these two buttons, they are in the off position. Okay, and attenuation is also at 0 dB. This should be kind of an initial configuration of these buttons. Frequency, anyway, you will be reading that which range, so you will not be confused. But for example, if you don't pay attention and suddenly this 40 dB attenuation is already on, and if you don't pay attention over here, you will be always assuming that you are giving the full signal, whereas actually you will be giving 1/100th of the signal over here. Okay, so to avoid the confusion, make sure that this is your initial setting. Now, in some cases, which actually is not required in any of our experiments, but if you want to change the symmetry of the signal, okay, this is for the sine wave, and let's say you also have a square wave or rectangular wave. You want to change the duty cycle over here. So for example, you want to generate a signal like where the on time is very small and the off time is very large. So that means you have to add some asymmetry to the signal. In that case, you rotate this knob clockwise, okay, and then you will be seeing that you will be either going in this direction, or you will be going that your on time is very large and your off time is very small. Something like that. You will be going in this direction. So depending on whether you want to use a high duty cycle signal or low duty cycle signal or 50% duty cycle signal, you use this symmetric button. Okay, but in most similarly, what you will see for the sine wave also, you will say you will get that the sine wave becomes very asymmetric, something like that, or it will be something like that, depending on. Just play with this button and you will realize yourself. Okay, but otherwise you just keep it in the off position. Now we come to the DC level. So what is the meaning of DC level? So normally when you talk about a AC signal or sine wave, on the y-axis you have voltage and on x-axis you have time. Okay, and this baseline for the sine wave is at 0 voltage. This is an ideal AC signal. Okay. Fine. Now you want to add some DC component to that. That means the sine wave will be superimposed with the DC voltage. So for example, in that case, your sine wave will look like this is your 0 level, and the sine wave will basically become like that. So where this is your DC, and then on top of this DC you have this AC sine wave. So this is called as a DC level. So here the DC level is equal to 0, But in this case, the DC level is non-zero. So that's why if you want to move your sine wave above the zero line or below the zero line, you need to add this DC level, and for that you will be using this button. Okay, I think you can try some experiments with the DC level and you will see. For example, if you want to use this this sine wave without DC level for amplification, then simply your sine wave will get amplified. So for example, here this amplified wave will look like after amplification. But in this case, this is let's say DC voltage of 2 volt and the gain is 5. So the DC level will also go to 10. So gain is 5 times 2 is 10. So now this is a new DC level, and on top of this new DC level, your amplified sine wave will sit. Okay, so in this case your both DC and AC both are getting amplified. In this case your DC is 0, so simply the AC level is getting amplified. So that's why it's very important that you pay attention that what kind of DC offset, DC level or DC offset you are going to use in combination with your signal. If you are not very sure, make sure that it is in the off position as the symmetry signal. Okay, so I think I have completed all the buttons and knobs of the front panel. Now let's move to this experimental part where we actually use this function.